Ready, sir. क्लास में नहीं आ गए, क्लास में नहीं आ गए, कोई चालू नहीं सेवेंथ की है राइट। ये इसका होना चाहिए केमिस्ट्री का इमल्शंस कोलॉइड्स है ना ये। हाँ हाँ मिला मुझको ये वाला हीटिंग कैल्शियम नाइट्रोजन, ये भी इसका ही होना चाहिए। हाँ ये है अपना waves are basically protect body weight surface waves. The body weights interact with the surface waves and generate. Oh no. First statement say है कि earthquake waves are basically of two types, namely body waves and the Earth's crust is brittle in nature. Yes. Third only. Three only. वो सही है. Composite volcanoes के बारे में क्या कह सकते हैं? They result in explosive eruptions. Yes. They eject pyroclastic material. Most definitely yes. Pyroclastic materials and ashes accumulate near the vent, forming layers. Yes. On correct. Loose sediments are transformed into sedimentary rocks by the process of lithification. Loose sediments ना lithification. Lithification माने the process जिससे वो compact हो जाता है pressure की वजह से. We are talking about that. यार you people are supposed to be from 11th standard, right? How are you gathering here? All right, no worries. Temperature inversion के बारे में बता रहे हैं. This happens when normal lab ये तो सारे climatology के questions है आज जो पढ़ा रहे हैं उसके. ये इस बार ही आए थे. अभी के एग्जाम में आए थे. अच्छा आई थिंक आपको वैसे भी सारे क्वेश्चंस I'll discuss these. ये सारे क्वेश्चंस है ना ये अभी इनफैक्ट जब मैं टॉपिक क्लियर करूंगी ना आपको तभी आपको पता चल जाएगा. अरे आई जस्ट शेयर्ड ना क्या हो गया? आई एम लूजिंग कनेक्शन नाउ. You hear me? Right. Today now we are going to try to study look at climatology. Okay. In climatology, meaning we are going to study the climate in general. Okay. When we are looking at the climate in general, we are saying कि We are looking at the atmosphere, first of all, okay? I'll give you a general outline of the entire chapter and then we can study accordingly. तो पहले सबसे पहले atmosphere study करते हैं, तो atmosphere के अलग अलग components क्या होते हैं, उसका structure कैसा है, वो study करते हैं, उसके unique features क्या है, हर component की what is the requirement of all components, and what is the function of each component, if there be. Then what functions, we can look at those functions. What are the unique features? And we will look at the various layers of the atmosphere. Okay, those layers are important for us. And then we'll also try to study the very unique features associated with each of these layers. All right. Then we'll also look at the various concepts and associated phenomena. Whatever concepts or phenomena are associated with those particular layers of the atmosphere, we'll try to study those too. Okay. Shalika? And then the next thing that we look at is solar radiation. How we get, and should I make it larger? Okay. Next thing is we are looking at solar radiation, like how do we get insolation from the sun and how it is distributed throughout the earth. Okay, we don't get equal amounts of insolation all over the earth, right? So clearly we'll try to see what affects the variability of the insolation. And where do we get the most insolation? Where do we get a little less insolation? And what is the general heat balance of the earth? Okay, so heat budget of the earth is an important thing. We need to check that out. Okay, this is the first chapter. In the second chapter, the following topic after that, we are going to study 3 important parameters that define the weather. Okay, which are those: temperature, humidity, and pressure. Okay, sure. So you are trying to look for a very short cut of learning geography. You're looking for a very shortcut of looking geography, or very something that is very time concentrated. Your concepts okay? Yes. You will need to make time to revise those, because I see, even if I offered you notes, these are proper notes, like that's not a mind map or something where it will have all the necessary keywords within one. I don't have those kind of notes. So that I will be able to cope with my syllabus till this. How will you make more time? This is a difficult question. I could tell you make audio notes and listen to them. If somebody has audio notes somewhere, then try to listen to them when you're walking. Oh, you try to listen to them when you're taking a bath or having food or something like that, lunch, during meal time or something. I really don't know how you guys are going to manage your time. Because I've never had that crunch of a time ever. I used to attend your classes. Yeah, I used to attend your classes. Sure, yes, hi. Okay. No, I don't think I have seen you. Have I? I remember you guys, but I don't think I've ever seen you before. I think it was all online, right? So yeah. Okay. No. Questions are important because they'll tell you if you're missing any part of the concept. People listen now. Since Shaurya is asking this question, it's information for you too. If you are missing out on questions, that is not a great idea, because you need to solve those questions. If you are missing out on any major concepts during that, you'll understand that you're missing out on those concepts. So question solving is very important, very, very important. You can't miss out on that. If Bhaiya is conducting tests, to give those tests. However quickly you wish to appear, but do that. And then sit down for the answer sessions also, because, you get answers to that. Then you don't need to revise the whole concept all over again. You don't have to do it on your own. Yes. It comes first. Okay. All right. And where is that? After that, even if you concentrate on your SSB preparation first, and then later on even if you get a month or so to prepare for it, because you've already covered all the concepts, right? So even if you get a month or so to cover geography and the rest of the GAT thing, you should still be okay, Aishwarya. No, you don't think so? I think you'll be okay. Yeah, then that's perfectly fine.
I was just considering that I should be doing consistently doing these things from nowadays itself.
Yeah, you should. But once again, prioritize your the one that is coming up first, the personality thing, and then later on you can throw yourself full-fledged into this.
And upcoming 3 months, I have to make this.
Who is SSBs? Oh. Then as first come first serve. Whatever comes first, you prepare accordingly, and then so on and so forth. Because that is the only way to go about it. Are preparations similar for both the SSBs?
Yes, the levels really the syllabus, but levels is quite a
okay. So ideally, if you prepare for one, you should be prepared for the second also, right? Yeah, so it's not an issue. Then you prepare for the SSB first, and then prepare for the HLS exam. Have you already made notes of NCERTs? Great, then go ahead. If you have the keywords marked out over there, then yes, please go ahead and read it. Because you will remember, with that keyword, you're going to remember all the concept that you have studied earlier. So yes, most recommended. Problem solved. Bye-bye. We are back. All right. So the next thing that like I said, we are going to study 3 very important major parameters of weather, which is temperature, humidity, and pressure. Okay. So usko padhenge. So pehla wala chapter to is just going to be about atmospheric structure and the components and various layers and associated phenomena and heat balance. Okay. We're just looking at that. Achha. So this is the first ever part that we are looking at. We are looking at the structure of the atmosphere. Okay. What is the atmosphere basically? We can say that the atmosphere is that thin blanket of gases which envelopes our earth. Okay. It surrounds the earth like an envelope and it is held in place by the gravity. Okay. So clearly you understand that the way gravity works is that the farther these gases are from the surface, the lesser the control of the gravity. Okay. The lesser the gravitational pull for them. Okay. All right. Do you understand this? So we are saying that so clearly the layers of the shall be thicker and denser, and those which are away from the surface of the earth will be a little rarer because the gravitational pull will be a little lesser. Okay, clear so far? So we are looking at this. What kind of gases are contained within this atmosphere? You have nitrogen, oxygen, helium, argon, carbon and dioxide, neon, helium, krypton, xenon, hydrogen, water vapor, ozone, etc. These are the very many gases. Okay. The first thing that we are looking at is not necessarily nitrogen. We can begin with nitrogen. Chalo, nitrogen se shuru karte. Nitrogen is necessary to dilute that oxygen part. Okay, you understand, right? Pure oxygen cannot be just it is highly combustible. So you cannot just deal in pure oxygen like that. All right, even Lay's, you eat Lay's, right? It is filled with nitrogen, right? It is because you need to preserve the food as well as not have any, how do you say, any kind of biochemical reactions. So clearly nitrogen is that thing, okay, for keeping that out. The next gas that we are looking at is oxygen. Why is oxygen important? Because it is necessary for survival, correct? For all living things, oxygen is very necessary, okay? Then you come to the next 5 gases, 4 important gases. Ozone. Ozone is important because ozone keeps out the ultraviolet radiation. And if that ultraviolet radiation was not filtered out by ozone, it would have reached us and caused all of us for skin cancer. Okay, so we do not want that. So ozone works well for us. Water vapor and carbon dioxide are important here. And since we are because water vapor and carbon dioxide are present in a large amount in our atmosphere. Okay, what happens apart from water vapor, carbon dioxide, ozone, nitrous oxide, and what am I missing? Methane. Okay. These 5 gases are famously called as greenhouse gases. Okay. We said water vapor, carbon dioxide, methane, nitrous oxide, N2O, and ozone. Okay. 5 gases, very importantly, we are calling them greenhouse gases. Let's understand the concept of a greenhouse. What is a greenhouse? We say, does anyone understand the concept of a greenhouse? Do you already know what a greenhouse is? What is a greenhouse? Very good. Absolutely correct. So greenhouse is an artificially created glass enclosure, mostly glass enclosures, because you wish to create a certain temperature and create a certain environment for plants which do not necessarily thrive or grow in that particular climate. Okay, so you control the climate within that small space, within a localized space. Okay, and that is done through glass. The reason why we do that through glass is because glass has this very interesting property that it will allow to pass the sun's shortwave radiation. Okay, the sun's rays come in the form of shortwave radiation. Okay, high energy shortwave radiation. All right. Okay, and when the sun's rays reach the earth, they will heat up the earth. The earth also becomes a radiating body and it emits long wave radiation. Okay, because it is not heated a lot, right? You've studied that law, Stephen Blackman. What was that law about radiating bodies? Have you studied those? Stephen Boltzmann, right? Stephen Boltzmann. You studied those laws, right? About radiating bodies. The amount of radiation emitted from the body will depend upon the temperature of the body, right? Agreed. So we are saying that clearly the Earth's temperature isn't so much. So the kind of radiation that the Earth emits is a long wave radiation instead. Okay. Now what this glass does is that it will allow the sun's rays to come in, but when the Earth starts to emit that radiation, it will not allow that radiation to pass. Okay. So if that radiation is not allowed to pass throughout that glass enclosure, what happens? That entire heat and radiation remains trapped inside that enclosure, raising the temperature and thus helping the plants over there. Okay, this is how the greenhouse works. I'll give you, when you're not intending the greenhouse effect, I'll give you an effect that you experience like this. Let's say you take a car, okay, wind up all the windows and go and park it in the parking, open parking space in the mall. Okay, come back after 2 hours and try to sit in it. You will feel the blistering heat. You will feel the heat. It is very hard to sit inside, right? Because now what has happened is that all the sun's heat has filtered in. Okay, that was allowed to pass in. But when the car tried to give out the heat and radiate it outside, it was not allowed to pass because that was long wave radiation, right? So that was not allowed to pass. So all that heat is inside. This is this is a kind of a greenhouse effect that you feel. Okay. So we are saying that all these gases, water vapor, carbon dioxide, ozone, nitrous oxide, methane, okay, these are all important for giving us the greenhouse effect. Now that greenhouse effect is important for us. I know we have abused that too much and that has become a problem for us and transformed itself into global warming. But greenhouse effect is essentially important for us because it keeps this Earth's average surface temperature. If we did not have this atmosphere, if we did not have these greenhouse gases, which kept the heat in and inside the atmosphere, our normal average surface temperature would have been minus 18 degrees Celsius. Would we have been able to survive then? Clearly not. Okay. Goldilocks zone or not, we would not have been able to survive with that. Okay. So now the surface temperature is close to 15 degrees Celsius, which we are happy with. We can clearly survive with that. Okay. We can work with that. So the greenhouse gases are actually important. They're necessary for our survival. Okay. ठीक है. Water vapor का एक समझना चाहिए. You should understand this about water vapor, that the amount of water vapor will always decrease with the altitude. Okay. As in how you go away from the surface, it will decrease. Say from the equator, at the equator you will find a lot of water vapor, but the farther you go away from the equator with latitude away from towards the poles, you will find that the levels of water vapor or the concentration of water vapor keeps on dropping. Okay, clearly the air becomes drier. At the equator, the air is clearly much more moist. Okay, even with increasing altitudes, you will realize that the air becomes much more drier. The amount of water vapor present is more in the lower layers than in the upper layers of the earth. Okay, is this good? Earth and atmosphere, sorry. Oxygen we already discussed. It's very necessary for all organisms to survive. Dust particles are important. We find those also in our atmosphere. These particles are important because they're hygroscopic in nature. What happens is that when they reach higher levels of Earth, of the atmosphere, not Earth, when the higher levels of atmosphere, these water particles, water droplets will condense around them. Okay, and these will come together, accumulate together to form clouds. And this is important for us because that's how we receive precipitation. So these dust particles, your salt particles, these all become important for us. Once again, dust is something that you find more in the tropical or subtropical regions where clearly moisture content is a little lesser. Okay. Dust, how can dust be generated if the moisture is less, right? Dryness. Dust is generated in dryness clearly. So you will not find that much on equators. Please remember, people, equators is that very moist, humid place where it rains every day between 2 to 4, okay, or 4 to whatever, 5, 6, whatever, okay. But every late evening, it is going to start raining. late afternoon, it rains every time on the equator. It is a very rainy place. Okay, equators are rainy places, and they are clearly cloud covered. Okay, always, because it keeps raining every day, so they are clearly cloud covered. So these are places where you will not find much dust, but more of the dust will be found in tropical, subtropical regions. Okay, this is once again something that UPSC asks you, so pay attention to that. Now we are looking at various layers of the atmosphere. Can you see those? Now you can see those. Good. Okay. So these are the various layers of the atmosphere. You start over here. You say the lowest layer is troposphere. Then above that you have the stratosphere. Okay, above that you have the stratosphere. Above that you have the mesosphere, and then the thermosphere, and then the last layer, the outermost layer, should ideally be the exosphere. Okay. Of these layers, the sector to remember that is trust me in the exam. Okay. You had this before? Yeah, you've been told this before? Good. Very good. This is that we are saying this is trust me. Remember, this is ionosphere. Thermosphere, the lower part is supposed to be ionosphere. Okay. So trust me in the exam. Okay, that is what we are saying. So trust me in the exam is going to be a setup for troposphere, followed by stratosphere, followed by mesosphere, followed by thermosphere, of which ionosphere is the lower part. Okay, and the last layer being exosphere. Okay, is this clear? Right? Now you have to understand this part about it. Can you see these little lines over here? Mesosphere, 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 no mesosphere. Okay, okay. Here we are. Try to look at this. Can you follow this red line over here? Can you look at this? Mesopause, stratopause. I'll explain those. I'll explain those. ठीक है. Troposphere, ये दिख रहा है आपको? Troposphere दिख रहा है आपको यहाँ से? हाँ, ये पूरा. Can you make out this dotted line? Okay, that is showing you the troposphere. All right. Then the line above this is going to show you the stratopause or something. All right. But now let's see this. So we are saying the troposphere. In the troposphere, if you see this red line, it is an indication of how the temperature is dropping as altitude increases. Okay. So in the lowest layer of the Earth, of the Earth's atmosphere, the troposphere, what happens is the temperature, as in how the altitude increases, the temperature keeps on dropping. Okay. Okay, fine. What happens then after that? After the troposphere ends, the next layer is ideally the tropopause. It is a small, how do you say, buffer layer. Okay. It's a kind of a buffer layer between the troposphere and the stratosphere. Okay. And that maintains the temperature. It holds the temperature. It is called as tropopause because it will hold whatever temperature was held at the troposphere. It will hold that temperature steady, and then it will transfer that same temperature to the upper layer of the tropopause, from which the stratosphere will also pick it up. Okay. Okay. So from the now see what happens in the stratosphere. With increasing altitude, what is happening? With increasing altitude, clearly the temperature starts rising. Okay. Here in the next layer, with increasing altitude, the temperature starts rising. Okay. Once again, it is held steady in the stratopause, which occurs after the stratosphere. Okay. Okay. And then after that comes the mesosphere. Once again, the temperature starts to steadily decline with increasing altitude. Okay. Fine. All right. And again, it is held constant at the mesopause. Okay. But that same temperature is held constant at the mesopause. And in the next layer after that, in the thermosphere, clearly that temperature starts to rise very, very steadily with increasing altitude. Okay. Thermosphere ke temperatures are supposed to be the highest. All right. Okay. So thermosphere ke temperatures keep on in the thermosphere, clearly in the layer of the thermosphere, the temperature keeps on rising steadily with altitude. And that is it. Okay, we are not concerned with the exosphere. Okay, we do not have much gas to sit and wonder how much the temperature is rising or not rising or whatever. All right, is this good, people? Do you understand this? We are saying that ideally the layers are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. And within these layers also, within the troposphere and stratosphere, exists the tropopause, which will hold the temperature steady for the troposphere. Okay, between the stratosphere and mesosphere, you can see the stratopause again, where the temperature is held steady. Okay, so whichever the lower layer is, that pause. Okay, if the lower layer is mesosphere, then the layer beyond it should be mesopause. Okay, got it? Where the temperature is held steady. Are we good, people? All right. ठीक है? All right. Is still settling. This is a good indication. I would have started rattling off new facts if I had not been able to see that your screen hasn't settled yet. Okay, now that your screen is settled, we are looking at the structure of the atmosphere. Okay, now when we say we are looking at the structure, we are going to study each layer and all associated phenomena or important, processes related to it. Okay, okay. Once again, start here that the density of the atmosphere is going to be the highest near the surface of the earth. Okay, whenever you're closer to the surface of the earth, the density of the atmosphere is always going to be highest because gravity works best over here. Okay, the farther you go away from the surface of the earth, the gravity will not be able to hold the gases. Okay, so clearly the blanket of gases keeps on getting thinner and thinner as you go away. Okay, now this is what you need to see. This is the how do you say, heights of the layers, okay, of the various layers. This is the first layer, the troposphere. Okay, the height of this layer is anywhere between 8 to 18 kilometers from the surface of the earth. Okay, now the reason why we say 8 to 18 kilometers is because at the equator clearly the layer is a little thicker, okay, and the layer is a little higher. Clearly the or the height of the layer is clearly higher. Okay, and at the poles it is clearly a little lesser. Okay, the reason being, to understand that what is happening at the equator is constantly convectional currents are being set up. The earth gets heated, the air becomes warmer, it rises upwards, and then convection currents are set up. And because of that, clearly the atmosphere, because of that updraft, continuous updraft, what happens is that clearly that layer of the atmosphere increases. Okay, so clearly the height of the troposphere is greater at the equator, anywhere between 8 to 18 kilometers, okay, between the equator and the poles. The next layer, the stratosphere, ends at 50 kilometers from the surface of the earth. Okay, so we are saying anywhere from 8 to 50 or 18 to 50 lies the stratosphere. Okay, okay. Uske baad, from 50 to 80 kilometers, you will have the mesosphere. All right, that is that layer. And from 80 to 400 kilometers anywhere, you will have the thermosphere. Okay, ye sare mil gaye? All right. Now we'll go to the very first layer. Yeah. It is. Yeah. It is important to study those numbers. They sometimes ask you that how far is this layer stretch? Troposphere from 8 to 18 kilometers. Then mesosphere ends at 50 kilometers from the surface of the earth. Sorry, stratosphere ends at 50 kilometers. Mesosphere ends at 80 kilometers. From 80 to 400 kilometers, you have the thermosphere. And that is all we are concerned with. We are not that concerned with the this, what do you say, exosphere. All right, okay. Chaliye. Now the very first layer of the earth, we are looking at troposphere. Okay, lowest layer of the earth, clearly. Okay, and it will contain almost the atmosphere once again because the atmosphere is the densest over there. Okay, so half the volume of the atmosphere is contained over here. Okay, now troposphere, like we discussed, it will go anywhere from 8 to 18, denser at the equator and less dense at the poles. Okay, this layer is very important because it contains water vapor and dust. So whatever weather-related phenomenon you'll find, all sorts of thunderstorms and lightnings and clouds and precipitations and tropical weather. What is happening? One minute, okay. This needs to be working in a working condition, right? Okay. Here we are. We say that all weather-related phenomena will always occur in the troposphere. Okay, air is always warm near the surface because and always a little colder as and how you go upwards. Okay, the farther the altitude increases, the higher you go. Clearly, the air becomes colder. This you can go from from climbing a hill or a mountain. You clearly know that, right? That the air is always colder above and a little warmer below. All right, okay. There is another concept that because this works, there is a rate at which the temperature of the air keeps falling. Okay, so that rate is called as normal lapse rate. Okay, isko in technical terms it is called as normal lapse rate. The normal lapse rate says that the air temperature decreases by 6.5 degrees Celsius every kilometer, okay, or 1 degree Celsius every 165 meters, okay. That is the what do you say, equation that you need to remember. That the rate at which the temperature decreases is 6.5 degrees Celsius per kilometer, or 1 degree Celsius per 165 meters. All right, okay. And clearly the tropopause will separate the troposphere and the stratosphere. This we need to understand. This we've already looked. The tropopause will hold whatever temperature was held at the upper layer of the troposphere. Okay, it will hold that temperature steady. Is this good? Huh? Do you understand this? All right. Okay. Remember the normal lapse data. You'll get many questions based on that. Okay. The next layer, the layer after that is the stratosphere. Okay. Stratosphere जो होता है, it extends up to a height of about 50 kilometers from the surface of the earth. Okay. It is the lower layer of the stratosphere that is more important for us, that we call as the ozonosphere, because it contains a lot of ozone. Okay. Now what happens is that when that ozone, you remember we were saying that the UV light gets filtered, UV rays get filtered over there. All the UV rays are absorbed by the ozone. So clearly because of that heat component, the temperature of the stratosphere keeps on rising. Okay, because the ozone filters out or absorbs all the UV rays, its temperature keeps on rising, and because of that, you will see that in the stratosphere, the temperature steadily increases with increasing altitude. Okay, you need to remember this. This layer is dry. It is very still and calm. You do not have any weather phenomenon because you do not have water vapor. You do not have dust. Clearly, not so much density of air also. So you will not have any kind of weather phenomenon. If you're not having any sort of weather phenomenon over here, this makes it the ideal place for jets and commercial aircrafts to flow. Okay, so mostly the long distance flights, whatever long distance flights you have, they usually go from here. Okay, they usually take the stratosphere and then cross over. Okay, that's how it works, because then you get to avoid all that drama that goes on in the troposphere. Okay, ठीक है. Stratosphere जो होता है, that separates the stratopause जो होता है, that will clearly separate the stratosphere and the mesosphere. Okay, this you need to understand. ये वाले pretty clouds नजर आ रहे हैं आपको, ये आपको usually stratosphere में मिलते हैं. Okay, these are called as polar stratospheric clouds, or another way of calling them is also nacreous clouds. Okay, now the thing with nacreous clouds or polar stratospheric clouds are that these are usually they are formed in cold winters at high altitudes and high latitudes. That is where you find them. Polar regions where they mostly. These, and since they are very high clouds, they are not made up of water droplets. They are purely made up of ice crystals or ice pellets. Okay. Now the thing with it is, they look very pretty. They are called as rainbow clouds because clearly the light effect is giving you all this. But the funda here is that they will what happens is the chemical reactions that happen within these clouds. Okay. Usually what happens is the CFCs, you understand CFCs, chlorofluorocarbons, right? The ones that we use in refrigerants and stuff like that. Yeah. Refrigerants. So those CFCs react, they get a base, they get a proper base, okay? With these ice pellets, they get a proper base. They react, the UV light and the CFCs and everything and all reacts. And what it does, it consumes all the oxygen. The chemical reactions will consume all the oxygen. They will break down the ozone first, okay? And they will consume all that, break down the ozone, transform it into oxygen particles, oxygen molecules rather. And they will free up chlorine, okay? And this is not a wonderful, clearly the ozone keeps on depleting very quickly after that, okay? And that reactive chlorine is left to its own devices after it. And you clearly do not require that effect, okay? That will just deplete the ozone very quickly. It is said that one single chlorine atom can affect about 100,000 ozone molecules. So clearly that is not the equation you want, right? That is a very, how do you say, too rapid a declination, right? Decline. So clearly that causes a very rapid decline of the ozone layer. I don't recommend it. Okay, these polar stratospheric clouds, even though they look very pretty, you please remember they are also responsible for ozone depletion. Okay, okay. That, sorry. Because you need high temperature, you need high latitude and high altitude for that. And you need how do you say, the temperature at which the dew point has to be lower than the freezing point, and that can only happen at very high altitudes, and clearly latitudes also, because then it is colder there. Okay. Next one is mesosphere. Okay, the next layer is meso meaning middle. So now you are at mesosphere. You want to go wash your face? That should help, right? Okay. So we are looking at mesosphere now. Okay, mesosphere is the layer above the stratosphere. Okay, Now, this layer happily is the coldest layer. Okay, this is supposed to be the coldest layer of the atmosphere, and the coldest temperatures are reached in the uppermost layers because the temperature keeps dropping, right? As in how once again in this layer the temperature is dropping with increasing altitude, right? So the coldest layer is always the coldest temperature is always the one that is at the top of the mesosphere. Okay, or rather the mesopause will also hold that same temperature. Now this temperature जो होता है अब ये वाला this layer is important because यहाँ पर in this particular layer the meteors burn up and you will clearly see that phenomenon called as shooting stars. Okay. Now the thing with the meteors is normally when they come in meteoroids, which two? Now we had troposphere first and then we had the stratosphere. Now we are looking into the mesosphere. Okay. Okay. So we are saying that this layer is important because the meteors burn up in this layer. All right. Imagine what is mesosphere? Shooting stars is mesosphere. Yes. What we are saying is, look at the two layers above it. Okay, you have the thermosphere and you have the exosphere. Clearly, you do not have a lot of density of gases. Okay. Now, what happens is these meteoroids are usually smaller things. Okay. Now, if that's a large thing, like if that's a large object instead of a smaller one, what happens first of all this will come down very quickly. Okay, it is going at a high speed, right? When it enters the Earth's atmosphere, clearly comes down very quickly. Okay, there is not much gas in the thermosphere or the exosphere. Okay, but there is some amount of gas, some amount of density found in the mesosphere. Okay, so when it comes down, what happens is that extremely high, rapidly approaching accelerated meteoroid is coming your way. It enters into the Earth's atmosphere. Now it is called a meteor. And now when it comes in, the moment it finds some amount of air, it will compress that air. Okay. What happens when air is compressed? Temperature increases. Okay. And that temperature causes this rock to literally disintegrate. It's a rock, right? At the end of the day, meteor is just a rock. So it will cause it to disintegrate and burn and all that sort of thing. If it is small enough, it will burn within the atmosphere because the temperature increase due to compression is very high, clearly. So it will burn within the atmosphere. If it is large enough, then it does not burn within the atmosphere. It will go and impact the Earth. And when it does so, it will be called as a meteor. Okay, we call that a meteorite. All right, okay. Are we good here? So we are looking at you understood all the phenomenon in troposphere. You're going to find all sorts of weather phenomenon. Okay, varish and everything. You're also going to find over here rains and clouds and storms and cyclones and everything. In the stratosphere, you will have commercial jets flying and these polar stratospheric clouds that you need to be careful of. Okay, not to be, but we have to be careful about the CFCs. The clouds are going to be formed one way or another. We just have to be careful about the CFCs. Okay. The mesosphere is important because it is the coldest layer and you will have this shooting stars phenomenon over here. Okay. Now you come to the thermosphere. Okay. Thermosphere is that layer that will extend from 80 to 400 kilometers that we discussed already. What happens to the temperature? With increasing altitude, temperature keeps on increasing. Okay. And the lower layer of this thermosphere is called as ionosphere. Okay. Remember, it is the lower layer of this thermosphere will be called as ionosphere. It contains those ions and they will reflect the radio waves. Okay. This layer of ionosphere is going to reflect the radio waves that are transmitted from the Earth. Okay. And it has a very low density. It has a very low density. You were asking me about the Earth's crust. Yeah. Crust, how does it vary? Average thickness of continental crust is 30 kilometers. Average thickness of oceanic crust is 5 kilometers. The reason being that continental crust usually is pretty permanent in nature, right? I mean, it can be broken, but it is not like destroyed and rebuilt every single moment. Whereas the oceanic crust is constantly being recycled. So clearly it is much thinner than average. Okay. So we checked out the ionosphere. That is important because it is going to reflect the radio waves. Okay, so that ionosphere becomes important for us. And please remember that this is the layer in which usually most space shuttles or even the International Space Station is going to orbit. Okay, it is this layer, thermosphere. All right. Auroras will occur in this layer. We are looking for auroras. You can see auroras over here, right? So auroras will usually occur in this layer. That's important for us. Okay, important as in that's an important phenomenon associated with this particular layer. Have you seen auroras before? Have you seen these things before? Yeah, you've seen them? Auroras are simply, it's a display of light, people. At the end of the day, an aurora is simply a display display of light. Okay, what happens is you can call them as polar lights because they usually happen at the magnetic poles of the earth. You understand, no? The North Pole and South Pole are different, the magnetic poles are different. So we are saying it usually happens at the magnetic poles of the earth. And you can call them if you're in the northern hemisphere, they're called as northern lights or aurora borealis. If you're in the southern hemisphere, they're called as aurora australis or southern lights. Okay. Usually what happens is, I'll tell you the phenomenon. Remember, I had spoken about the solar winds. I had said that the Earth's sun is so hot. Okay, the sun is so hot that it cannot even contain its outer atmosphere. Okay, even the gravity cannot contain its outer atmosphere. So all those charged particles from the outer atmosphere of the sun come into a steady stream towards all the planets. Okay, all outwards from the sun. Now that is called as solar winds. We call that as solar winds. All right. Okay? Now these solar winds, these charged particles from the solar winds usually precipitate in the upper atmosphere. Okay, so in the thermosphere clearly. So they precipitate over there. They come in contact with the particles of the atmosphere. Okay, and they impart the energy to these particles. Okay. Now when these particles get energy, chemistry mein padha hoga na, they get excited. Okay. And if they get excited, they are also going to release that energy. So when they release this energy, it is in the form of these varying colors of light and complexity. Okay, so that is why you get these beautiful displays of beautiful. These are really beautiful. Mostly you will see these green and yellow things because they are happening at a lesser altitude. Okay, if you see that at a really high height, say about 300 kilometers or so or something like that, then clearly the display will be a little reddish in color, reddish hues. You can see those reddish violetish hues there. Okay. So mostly this is because the atmospheric particles get a little charged and get a little excited when they come in contact with the solar winds, so the particles from the solar winds, and that is why when they emit that light, when they give off that extra energy and come back to their normal state, stable state, this is the kind of display that happens. Okay, fine. Is this good? This is what we call auroras. Okay, now that we have studied the auroras, we can also go back to the exosphere. Okay, we have done with the other with the thermosphere. We go back to the exosphere. We say exosphere is the uppermost layer of the atmosphere. The gases are very, very sparse. In this, what you'll mostly find is hydrogen and helium. Hydrogen being more than helium. Okay, but this is what you'll generally find over here. And density of air is very less because clearly the gravitational pull is too less. Okay, so that is why the gas doesn't stay there. It keeps on escaping. There is one more thing that I want to introduce, the Kármán line. Okay, this Kármán line that will occur, say about, this is our definition. We say about 100 kilometers from the earth. We say that is the Kármán line. So that will separate the Earth's atmosphere and the outer atmosphere. Though we say that the Earth's atmosphere extends all the way up to thermosphere and exosphere, but the relevant for us is just up to the Kármán line. Okay, so we say that much is the Earth's atmosphere, the rest is just outer atmosphere. This is for people, outer space. Okay. What is the temperature at exosphere? I have no clue. I can check out. Very less, right? Because there is no gas release. It should be, but I don't know how freezing. But it should be really freezing. Sorry, what? Right, solar activity. Oh, what is wrong with me? I'm sorry. Clearly, there is a lot of solar activity, right? We are looking at clearly all those solar winds precipitating and stuff like that. So clearly, the temperatures are very high. How to? They go with a lot of this. What do you say? They have proper suits and all, space suits and all that designed to withstand that whatever they are going to face. That is there. See, you're saying you might not feel that because temperature here will refer to the speed of the individual molecules, right? Okay, okay. No, not this. We are here. Okay. Now we go to the next topic, which is the solar radiation and heat balance. Okay, you're looking at the solar radiation and heat balance. Let's try to understand the concept of insolation first. Okay, what is insolation? We say insolation is the incoming solar radiation. Okay, properly, it is just a short form, acronym for it. Incoming solar radiation is insolation. Okay, like whatever. Here I am not going to put you on my hotspot. And you stopped scaring me for this particular internet. Wait a minute. Why can't I see myself? Good. We'll stay on my phone. Okay. Here we are. So we are saying that the insolation is the incoming solar radiation. Two concepts that we need to study over here. You realize that the Earth orbits the Sun. Okay. And that orbit is an elliptical orbiter, right? Okay. So clearly it is not going to stay at constant distance from the Sun. Always it won't be at a constant distance from the Sun. Okay. There will be a time when Earth is farthest from the Sun, we call that as aphelion. Okay, aphelion बुलाते हैं उसको, and that occurs on around 4th of July. Okay, every year that will occur around 4th of July. And then when it is closest to the Sun, that phenomenon we call as perihelion. Okay, helion refers to the Sun, aphelion meaning दूर and away, and peri means closer. Okay, so perihelion is when the Earth is closest to the Sun. That occurs on usually around 3rd Jan. Okay, that will usually occur around 3rd Jan. Please remember the dates. UPSC once asked you this question. Okay, okay. Now we will study about the variability of the insolation. Okay, we say that clearly the amount of solar radiation that you receive everywhere is not always the same everywhere. Okay, clearly it will vary depending upon the altitude, upon the latitude, upon the cloud cover. There are many other things that will matter. So we are going to check out the list of factors that will affect the variability of this insolation. How much sunlight you will get. Okay, we are looking at that. First of all, inclination of the Earth's axis. Remember what we had said. We had said that the Earth is inclined at the angle of 23.5 degrees to the vertical axis, right? Vertical axis. The Earth is inclined at an angle of 23.5 degrees to the vertical 23.5. Very correct. That is why the Tropic of Cancer and the Tropic of Capricorn fall at 23.5. If the Earth were inclined at 20 degrees, the Tropic of Cancer and Tropic of Capricorn would have fallen at 20 degrees, north and south. The reason being that since the Earth is inclined that much, we say that the Sun can ever only give barabar 90 degrees. Say the Earth can only ever be overhead at that angle. Okay, only at that particular angle the Sun can ever be overhead because the Earth is inclined that much. Okay, okay. So since the Earth is inclined at 23.5, the overhead Sun's limit is marked at 23.5 degrees north and 23.5 degrees south, which we call as the Tropic of Cancer and Tropic of Capricorn. Okay, good so far. Are you with me so far? Okay. Okay. So we are saying it is because of this. So clearly within the tropics, you're going to get a lot of insolation. Okay. Outside the tropics, what happens? The rays of the Sun will be received in an inclined fashion. Okay. Most of the rays of the Sun will appear in an inclined fashion. And the more inclined the rays are, lesser the insolation. Okay. Please remember, the farther the latitudes are from the equator, the lesser the insolation received. Okay. This is normal. This is very logical. You can get that. Okay, so clearly, the Earth's inclination is also location of place. What the latitude is, that is also very important. Usually, lower latitudes will get more insolation as compared to higher latitudes. Okay, presence of clouds. The thing with clouds is that once clouds form, what they do to sunlight is, say, suppose this is the cloud. Okay, so when the sun comes, it is directly reflected back by the clouds. But the sunlight is directly reflected back by the clouds. Okay, so if a place has a lot of clouds, then clearly that insolation is not going to percolate. No matter. So, for example, the equator. Okay, we think since it's somewhere nearby to get a lot of insolation. That's not true because half the day on the equator is spent under cloud cover. All that sunlight that comes in gets reflected back. So clearly, a lot of places come in, a lot of pollution reaches the surface. Okay, cloud sunlight, and the thing to remember is maximum insolation that is found is somewhere in the tropical subtropics where you will not find any cloud cover at all. What happened? At the ISRA internet chala gaya. Because I can see everything. My internet is working fine. See, and there is मेरा internet but I on my this has lost its Wi-Fi. We can take a break if you want, until that Wi-Fi comes out. I should give it तो फॅन बंद होतोय परत आता चालू आहे पण आपण इतर कोणाला पडलं Hey, guys, I'm gonna break now for the next 2 minutes. Sorry. I was unmuted. I was saying that it is the presence of clouds that hinders the amount of insolation received. Oh, yes. Look, if there is a cloud formation, clearly the incoming sunlight will be reflected back, and it will not reach the surface of the earth. Okay, so you will find that the maximum insolation is received at the subtropical deserts where the cloudiness is least. Okay, because clearly there is no cloud formation in the deserts, right? You don't have enough moisture for clouds to be formed clearly. All right, so that is not happening there. Then we were discussing the passage through the atmosphere. We say that when the sunlight or when the solar radiation passes through the atmosphere, thank you, sir. When the solar radiation passes through the atmosphere, then these rays are, then this is, the light is scattered, diffused, absorbed, and so on and so forth. So clearly, the longer the inclination, the more the inclination of the sunlight, the lesser it is, how do you say, the less the probability of it being received on the Earth's surface. Okay, that is done. And lastly, you have the spatial distribution at the surface. This you have to understand. You will always receive more sunlight at the tropics than you will ever receive at the poles. Okay, always more sunlight at the tropics, less sunlight at the poles. Okay. Now you have to also understand that since it is not like the poles are always getting completely frozen and the tropics are constantly being heated. ऐसा तो नहीं होता है. Right? Why does this not happen? Even though we know that there is a surplus net radiation between 40 degrees north and 40 degrees south, it does not always mean that the tropics are always constantly heated up and they're always constantly a little more. काय पाहिजे सर? अच्छा. नाही ते माझ्याकडे बघत होते म्हणून. Okay. And lastly, you have the what happens is whatever surplus energy or whatever surplus heat the tropics have gets redistributed through ocean currents, wind, planetary winds and all. So that distributes that energy so that the tropics do not get excessively heated and the poles do not get completely frozen. Okay, that works like that. Do you understand how insolation works? Do you understand the various factors which are which are responsible for the variability of insolation? Yeah. Okay. We are saying Earth's inclination, location, presence of clouds, the latitude, more importantly, the fact that it passes through the atmosphere. So that and the spatial distribution at the surface. Okay, that where the tropics will always receive more insolation as compared to the poles. All right. Now this is a very, very important page that brings questions as well as very important concepts for cyclones also. Okay. Here we are. These are the 4 processes which will help in the heating and cooling of the atmosphere. Okay, heat transfer, mass transfer के लिए ये 4 processes important है. We are looking at these 4 processes. Okay, the first process being conduction. Okay, conduction माने क्या? What happens is the particles of the medium come in contact with each other, and that is how energy is transferred. Right? That is conduction. Agreed? Transfer of energy. Transfer of energy through contact. That is conduction. So we are saying that normally what happens is the earth gets heated by insolation. Okay. Now once the earths get heated, the temperature rises, it itself becomes a radiating body. Okay. And it starts, and what happens is the earth gives out radiation in the form of long wave radiation. Okay, that is the form of radiation that the earth will, because it does not get a lot of, the temperature does not become as high as the sun, right? So clearly the kind of radiation that the earth emits is long wave radiation. Now this long wave radiation, say suppose this is the surface of the earth. Okay, we are saying this is the surface of the earth where the sun's radiation is received. Okay. Now the earth starts getting heated up and it starts giving out this long wave radiation. Okay. So the very first layer, the layer which is closest to the earth, will be heated up. The layer of the atmosphere that is closest to the earth will be heated up by this heat. Okay. Okay. So this is say layer 1. Okay. Layer 1 gets heated up. Okay. Then the second layer will be heated by contact with the first layer. Okay. The third layer will be heated by contact with the second layer. Okay, you get it? So this is how the heat transfer happens, okay, through the process of conduction. Please understand that it is not the sun that heats up the Earth's atmosphere. It is the Earth's long wave radiation that heats up the atmosphere. Okay, the lowest layer gets heated up by that, and then it keeps transferring energy to the uppermost layers. Okay, the layer above it. That is how conduction happens. Okay. So this transfer of energy is to achieve, basically to achieve balance. That is why it is happening. Because I told you, right, for anything to move, for anything to have, for winds to move, you need a pressure gradient. For electricity for current to run, you need a voltage difference. For water to run, you need a level gradient. Gradient ke bagair, without an imbalance, it is not possible for that movement to happen. So it is to achieve that balance that you will basically get this transfer of energy. Okay. So understand conduction. The second kind of movement of the process is, वापस बताओ. Oh, अरे यहाँ पे इंटरनेट का प्रॉब्लम है क्या? Anyways, you guys can still hear me, no? You can hear me. The second process is convection. Okay, we've already studied convection. What do you mean by convection? We say that when the sun's rays heat up the atmosphere of the earth, what happens is the layers of the those layers of atmosphere get heated up. Okay, the air gets heated. When the air gets heated, obviously it becomes lighter. Becomes lighter. It rises. It expands, and then it cools. Okay, and this is that vertical movement of air. You are saying this, because of heat, because of temperature, when the air rises and goes on to the upper layers of the earth, upper layers of the atmosphere, clearly that is called as the vertical movement of air. So that we call as convection. This vertical movement of air is called as convection. Okay, and this can only happen in troposphere because nowhere else this is going to happen. Okay. The next process is, what does convection help in? Formation of clouds. We know this, no? Once the air becomes lighter, it will go upwards. Okay, it will expand. When it expands, it cools down. When it cools down, it is going to saturate at some point of time. After saturation, condensation is going to happen. And when condensation happens, clouds are formed. When clouds are formed, clearly precipitation happens. Okay, so you're looking at that. So we are saying this process, the process of convection, is very important for precipitation and cloud formation. Okay, that process is important. This next process is very, very important. It is called as advection. Okay, advection means horizontal transfer of energy. Remember how winds blow from a high pressure region to a low pressure region? Which regions are usually, does pressure depend upon temperature? Yes. High pressure regions are supposed to be a little cold. Low pressure regions are supposed to be a little warm. Okay. So clearly this is also, when wind blows, clearly that energy is also going to be transferred. The heat is also going to be transferred. Okay. So we say advection is the transfer of heat through horizontal movement of air. And this is more important than the vertical movement because, these are for local winds and stuff. Huh? This process is important for local winds. When we study pressure, we'll try to see the importance of local winds. In middle latitudes, most of the diurnal variation in daily weather is caused by advection. Yeah, I told you about diurnal variation, right? In temperature or in weather. Diurnal variation meaning within a span of 24 hours in a day, you see the maximum or minimum temperatures, maximum or minimum pressures. That is the diurnal variation. Okay, so we are looking at that. So this is due to advection basically. For example, you understand Loo, you know about Loo, right? The one that flows in Punjab and Uttar Pradesh and that region. So it's a local wind that flows during summers, usually dusty. राजस्थान से शुरू होता है क्या? होता है कभी कभी. लू राजस्थान में भी चलती है. लू is a very typical local wind. But it can flow over long distances. Usually, it starts in the late afternoons and then it can go until or somewhere in the middle of the afternoon because you need the air to be really heated up in some place. Okay, and then it starts moving all the way in a different place. So usually dusty, very warm, and they can be very stuffy. Those loo can be very, very stuffy. The dehydration becomes a huge problem, and people might even die because of that. The extreme temperatures if not taken care of. Okay, so clearly lose that. So that is a very typical example of an advectional process. Okay? And the last being terrestrial radiation. We already studied that. We said that when the earth receives radiation, solar radiation from the sun, what happens is the earth receives that radiation and the temperature rises, it itself becomes a radiating body and starts to emit radiation. And that radiation is in the form of long wave radiation. Because clearly उसका temperature इतना नहीं पड़ता है. That is not it's not a very high temperature. Okay, and this long wave radiation is absorbed by the greenhouse gases and it keeps the atmosphere heated enough for the surface temperature to be 15 degrees Celsius instead of minus 18 degrees Celsius. Okay, take it. Cool so far. You with me now? You've understood all this part, right? Okay. Let me specify when we are talking about the heat budget of the earth, what we are discussing is we are discussing the amount of insolation received by the sun, by the earth and the atmosphere. Okay, and the amount of energy or the amount of radiation reflected or sent out by the earth and by the atmosphere. Okay, so we are essentially saying that the earth, neither the earth nor the atmosphere are in a net surplus or a net deficit of radiation or energy. Okay, what happens is whatever amount of energy is received by the earth or the atmosphere from the sun, the same amount of energy they both give out also. Okay, they keep nothing to themselves. All right, that is what we are saying. All these numbers, I have not seen UPSC ask you about these numbers, how many units are reflected by the earth, how many units are reflected by the clouds. All these numbers have not been asked by UPSC for at least 10 years now, as far as I know. We had done this long ago, sometime in the early 2000s they had done this. So at least for the last 10, 15 years, I don't think they had ever asked you, they have asked you this question, okay? But you need to understand the general concept. And the general concept is that a constant temperature is maintained on the earth and the atmosphere, because neither surplus energy is received, there is neither surplus of energy, not deficit of energy, okay, with the sun's radiation. Is this good? So we are saying that the earth on whole does not accumulate or lose heat, and whatever amount of heat is received from the sun is also returned back to the space, okay? Constant temperature is maintained at the surface and in the atmosphere, and we need to see this part, okay? Now look at this part. This is the shortwave radiation. Can you, is this, you're with me, okay? Okay, the figure to the left tells you about the shortwave solar radiation, meaning the radiation coming in from the sun. Okay, we say suppose the total radiation is some 100 units. Okay, let's say that is some 100 units. So we say 34 units of these are directly absorbed by the earth. Okay, the earth directly absorbs that. Then whatever amount of energy is released over here, of that 17 units are again absorbed. Whatever radiation is scattered and diffused and all, out of that also some 17 units are absorbed by the earth, okay, okay, and some 14 units are absorbed by the atmosphere. Agreed? Okay. And then 27 units are reflected by the clouds, and another 2 units are reflected by the earth, and finally some 6 units are scattered to the space. Okay, so this -6, -27, -2 is something that is reflected back to the space. Okay, whereas +17, +34, +14, these are all units that are absorbed by the earth and the atmosphere. Okay, look at this section. What happens with the long wave radiation of the earth? Okay, you can see, right? This is the long wave radiation of the earth. Now, with the long wave radiation of the earth, meaning we are discussing how much the earth has given off. Okay. Now, what happens is the earth gives off 23 units directly. Okay. Some 9 units are released through turbulence and convection. Due to all the weather phenomenon that happens, that releases some 9 units of energy. And some 19 units are released through condensation. Okay. Okay. Now, all of these 23, 17 units are radiated directly back to the space. Okay, and 6 units, these 9 units and these 19 units are reflected to the atmosphere, are released in the atmosphere. Okay, so tell me, how much did the earth acquire? How much was the how much did the earth acquire completely? These 17 units, and these 34 units, right? The earth that was directly absorbed by the earth. Agreed? How much is 17 and 34? Yeah, 51, no? 17 and 34, 51. Okay, that is the units absorbed by the earth. Okay, how much did the earth reflect? Look at this, 23, 9 and 90. This is the one that the earth reflected and gave out. Okay, how much is 23 plus 9 plus 19? 51 again. No, 51. Okay, so this is the I'm saying that whatever the earth has absorbed, it has also reflected back. Okay, now let's look at the atmosphere. All right, how much did the atmosphere receive? 14 over here, right? See over here, this 14, this is what the atmosphere received directly from the sun, and this while the earth was giving it out, it received over there. Okay, 6 units, 9 units, 90 got it when the earth's processes began, and these 14, the earlier 14 came directly from the sun. Okay, what is 14 plus 6 plus 9 plus 19? 48. Okay, that is 48. And look at the amount of units that were reflected directly into the atmosphere. Okay, we are saying these 17 and this 40. Okay, -17 and -48. This was directly given back to the atmosphere. So what is that again? Sorry, radiated to the space by the atmosphere should be 48. I'm not counting this 17. This came from the earth. Just this much. Okay, this 48 came from the atmosphere itself. Okay, so once again, I'm telling you the numbers are not important. You need to understand the process that whatever the earth receives, the earth reflects back completely. Whatever the atmosphere receives, pura ka pura, the atmosphere also reflects back completely. Okay, okay, and that finishes off this chapter. So let's study the questions based on it. Yeah, एक second. Let me. Let's start with the first question. Consider the following statements with reference to the structure of the Earth's atmosphere. 1. The thickness of the troposphere is greatest at the equator. Is it, people? Is the thickness of, yes, it is. Absolutely. It most definitely is. Okay. The thickness of the, where were we? The thickness of the troposphere is greatest at the equator. Okay. Second statement says the air temperature of the tropopause is highest above the poles. The reason being that what happens is, now you have to consider this part, people. We are saying that this is the troposphere. Okay. ऐसा तो नहीं होगा troposphere अपना. टेढ़ा होगा टेढ़ा. This is the surface of the Earth. Clearly, this is the troposphere. Okay, we are saying this is the near the equator. This is at the poles, and we are saying that this is going to be the height of the troposphere. Okay, and here is where your tropopause is going to be. If this is the troposphere, now, so this is going to be the T-pause. We are saying this is going to be the tropopause. Okay, okay. So we are saying the air temperature of the tropopause is highest above the poles. Now see, this distance is not much, clearly. Okay, that is 8 kilometers. Now, to the maximum, it can be 8 kilometers, right? So clearly, the air doesn't travel much high so that it can cool as much. Okay. Instead, at the equator, what happens is the air clearly travels way higher and cools much more, and clearly the much lesser, okay, as opposed to that near the poles. The thing is now, we logically think if it at the poles, it will be cold, okay? But see, normally at the poles, how freezing are temperatures? 0 degrees, a little less than that, but clearly it's higher and higher and way higher for really cold. So maybe here temperatures are somewhere between -40 to -60, but the temperatures are clearly -60, -80. Clearly, the temperature at the equator, the tropopause is, okay, near the equator, the temperature is less than they are at the poles. Okay, poles will be here at the tropopause. Clearly, the poles will have a much higher temperature than that of the equator. Okay, than that at the equator. Is this good? So we say thickness of the troposphere is greater than the equator. That is true. The temperature tropopause is highest above the poles. That is also true. Okay. The temperature in the troposphere decreases at the rate of 1 degree Fahrenheit for every 165 meters. No, we are saying it should be 1 degree Celsius. Correct? The actual answer should be 1 degree Celsius. Oh, you're there, yeah? Why don't you come and sit here? I keep forgetting that you're there. So clearly it is going to be 1 degree Celsius. Okay, so this, we cannot consider this as an answer. We'll have to let go of this. We'll have to go, it should only be B, 1 and 2. What would be our answer? Okay, next question kya hai? It is related to insulation. We can answer this question. Which of the following are factors that cause variation in the amount of insulation of the Earth? Okay, we are discussing which are the factors that are going to affect the insulation. Rotation of the Earth on its axis. That the Earth rotates on its axis, will it affect the insulation? What happens because the Earth rotates? What do we get? What is the effect of that? Day and night. Day and night, right? Does day and night affect the insulation? Yes, it does not. So in one sense, it is going to affect. Okay, so we say yes, rotation of the Earth on its axis is going to affect the insulation, because you don't get insulation at night, irrespective of whichever latitude you're at. Okay, length of the day, does it affect? Yes. The longer the day, greater the insulation. Clearly. Okay, distribution of land and water on Earth, that will affect the temperature. The insolation is the light coming from the sun. It doesn't matter what lies beneath it. If at that particular latitude, whether it is land or water or whatever, it is going to heat it up. But how it is going to get heated will depend on whether it is land or water. See, it will not directly affect the insulation. It will affect how that insulation translates into temperature, how it is absorbed. So if it is land, clearly it will get heated much faster. And if it is water, then clearly not so much. Okay. So this particular factor, this distribution of land and water on Earth, it will not affect the insulation, but it will affect the temperature. Okay. So we cannot include that in insulation. We'll again go with B, 1 and 2. Okay. That should ideally be our answer. Tropical storms हमने अब तक पढ़े नहीं है. We are not looking into local winds, neither these winds. Coriolis effect we haven't studied yet. Auroras we can study. Okay? Can you make, oh. Can you make out? Or should I increase the thing? Okay. I'll read out which of the following statements regarding aurora is correct. The first statement says that the solar wind, upon reaching the Earth's atmosphere, is directed towards the two magnetic poles, and a colorful display of lights is seen in the night sky. And that is the very definition of an aurora. That the solar winds reach the Earth's atmosphere, charge up the particles, they will impart energy to the particles in the atmosphere, and when they become unstable, they will emit light, and you can see all these displays of light. Okay. So this is correct. The particles interact with different gases of the atmosphere. Each gas glows with a particular. And this is also true. No? Every gas, according to its own nature. So you see that. In April 2020, aurora was captured in the night sky in India by the Indian Astronomical Observatory in Hanley, Ladakh. It was a very rare phenomenon. India is not famously known for auroras, right? We are pretty close to the tropics. We do not see auroras. You need to be at a high latitude and closer to the magnetic poles of the Earth for that, okay? But this was what had happened at that time, that there had been a great storm. And because of that, what happened was that there was something that is a coronal mass ejection. Okay, I'll just write that over here. Okay. Corona is the outermost layer of the Earth's atmosphere. Okay, so all those little particles from there, a steady wave or a stream of particles came and they converted into the Earth's atmosphere. Okay, into our atmosphere. And now it did not matter whether they came towards the poles or anywhere, and that is the reason why we could see it at Ladakh also. Okay. But the thing is, from Ladakh, what we saw was only the upper part of the aurora. So we saw the reddish part instead of the greenish part. Okay, so that is why we saw the reddish hue, which we normally see at very high altitudes. Okay, so that is why we saw that reddish hue thing, because we are a little closer, we are a little farther from. So what we saw was just the reddish part of it. Okay, so this is the thing that happened, and we had a great time doing that. You should see that thing. As Indian Astronomical Observatory, it does not. I checked it out yesterday. It does not allow nightly visits, so clearly you can't stargaze at night. However great the telescopes are, it has that Himalayan Chandra telescope. They show you around that telescope. You're allowed to visit. You should take permissions of 15 days before they say. But you clearly cannot, because it's a sensitive region, right? Or China border ke paas hai. So clearly you're not allowed to go. Nighttime visits are not allowed. But you usually stargaze at now. What do you need observatories for? You are not observing things during the day. You're observing things at night. So that is not possible. Stargazing is not possible. But anywhere in Ladakh, you can have your own telescope and start looking up, because it is closer. Na? It is in a dry region. Clearly, not a lot of weather activity going on at all. It is a great place for such stargazing and astronomical activities. Okay. So what should our answer be? All three are correct. 1, 2, and 3. We are going with D. All three are correct. क्लाउड्स नहीं कर सकते, फ्रंट्स नहीं कर सकते, ये कर सकते नहीं, ये भी नहीं कर सकते. We did not discuss temperature. Humidity नहीं कर सकते. No tropical cyclones नहीं. ये वाला. I'll wait until it's. Yeah, you're there. In which of the following layers of the atmosphere all weather phenomena occur? Mesosphere, troposphere, thermosphere, or stratosphere? Troposphere, absolutely. We are going with the answer troposphere. You see how simple these questions are? These are actual PYQs. Which of the following is not a main greenhouse gas? Water vapor and carbon methane. Water vapor, oxygen, carbon dioxide, methane. Oxygen. Oxygen is not a greenhouse gas. Ozone is the greenhouse gas. What did we say there are greenhouses? Vapor, carbon dioxide, ozone, and nitrous oxide. We said there are greenhouse gases. 5 major greenhouse gases. Not discussing anticyclones and not discussing clouds. Not this year. हो गया There should be some oxygen present there, but we don't want that oxygen to be present in the ozone layer. We want it to be in the form of ozone because oxygen cannot absorb UV rays, right? But ozone can. So we want the ozone to remain in that form of ozone. We do not want it to break up into O2 and OIC. We don't want those processes. That is a natural process there, right? So, but if getting depleted at such a high rate, then that's a problem. So we do not want this to go unaffected. It is the post-structural cloud. It is based for to happen in the hands of. So otherwise, it is the safe start causing the reaction. So you were saying key, do we require oxygen there? The oxygen is not a hindrance, but the depletion of ozone is a problem. If oxygen is coming from the depletion of ozone, then that's okay, wait. Right, whatever time if you want if you want till 5 o'clock, I'll be until 5 o'clock. Yesterday, my back wasn't helping me. So I was not at my best yesterday, so I left early, but I think I should teach you until 5. Now I'm worried if I go another holiday, I don't know how your portion is going to be completed because you are not available to me 3 days of the week, right? You have left. I yesterday you guys have tests and so you have 3 days of the week. Yeah. Wednesday and Monday, Tuesday, Wednesday, Saturday.
Monday, all days are there. One GAT paper, one max paper, one GAT paper, one max paper. That means in Monday max paper, next day it is GAT paper. Alternate.
So when are you available to me to learn to teach?
I don't know. They are just preparing for the super focus students. So
yeah, but if you are having tests during
I think that is not possible here.
So what do you think are possible? Yeah.
Reference are good. I think they say
this thing is unknown. I should say join from browser again. Like this. India online.
Join me, ma'am.
I can't see the join. You mean it is and we are
I'm saying I get last month. I don't know. I'm just looking that last month. In current month. Almost like I see I said it's possible. Like my still.
Something happened, right?
Ma'am, it's yesterday also. We doesn't eat. Sorry, we doesn't sleep at night because
there is no power.
no, ma'am. It was so difficult to sleep.
Clearly a problem. Anyway, no problem. I'll share you the screen. Okay? Wait. Me, by which of the following, short solar radiation, radiation, or solar radiation. I'm sorry, शायद it seems so. I don't know, but this whole thing is good.